Statistics and probability. Objectives. Number 1. Define statistics and probability. Number 2. Cite uses of statistics and probability. Number 3. Solve some problem probability distribution. Keywords. A. Random variable. B. Variable. C. Discrete. D. Continuous. E. Mean. D. Variance. E. Outcome. F. Event. Uses of statistics and probability. Lotto games. Dice. Bingo. This is how to compute 55 combinations of 6 numbers in a lotto. So they use the formula of combination. So the answer is 28,989,675 pesos in order you to get the right answer. For hospital, population, grading system. Other uses of statistics: collection of many data like height, weight, grades, and so on. It can be useful in predicting data. What is statistics? It is a branch of applied mathematics dealing with data collection, organization, analysis, interpretation, and presentation. A science concerned with developing and studying methods for collecting, analyzing, interpreting, and presenting empirical data. What are the two types of statistics? A. Descriptive statistics. B. Inferential statistics. What is descriptive statistics? It is able to describe and understand the features of a specific data set by giving short summaries about the sample and measures of the data. The most recognized types of descriptive statistics are measures of center, the mean, median, and mode, which are used at almost all levels of math and statistics. What is inferential statistics? A judgment of the probability that an observed difference between groups is a dependable one, or one that might have happened by chance in the studies. It is used for a random sample of data taken from a population to describe and make inferences about the population. What is random variable? It takes infinite or countably infinite numbers of values. Is called discrete random variable. A variable whose values depend on outcomes of a random phenomenon. It has a function that requires to be measurable, which allows for probabilities to be assigned to sets of its potential values. It is a common that the outcomes depend on the physical variables that are not predictable. Experiment of random variable. Head and tail, or toss coin. Dice. What is discrete random variable? Accountable in a finite amount of time. For example, you can count the change in your pocket. You can count the money in your bank account. You could also count the amount of money in everyone's bank account. It might take a long time to count that last item, but the point is, it's still countable. What is continuous random variable? It is a variable whose value obtaining by measure. Example, height of students, weight of students in class, and distance traveled between classes. Example of discrete and continuous. Discrete and continuous data. Discrete data can only take a certain values, while continuous data can take on any value in a certain range. Example number 1. Number of pages in a book is discrete variable. Example number 3. Shoe size is a discrete variable. Example, a size of 5, a size of 5.5, 6, 6.5, and others, not in between. Example number 5. Number of people in a race is a discrete variable. Example number 2. Length of a film is a continuous variable. Temperature is a continuous variable. Example number 6. Time taken to run a race is a continuous random variable. What is probability? The branch of mathematics concerning numerical description of how likely an event is to occur, or how likely it is that the proposition is true. The probability of an event is a number between 0 and 1, where roughly speaking, 0 indicates impossibility of the event and 1 indicates uncertainty. Probability. The higher the probability of an event, the more likely it is that not event will occur. A simple example is the tossing of a fair and biased coin. Since the coin is fair, the two outcomes, the head and tails, are both equally probable. The probability of heads equals to the probability of tails. Since no other outcomes are possible, the probability of either heads or tails is 1/2. Could also be written as 0.5 or 50%. What is probability distribution? Number 1. The mathematical definition of a discrete probability function is P sub x. It is a function that satisfies the following properties. It can be written as P sub x is equals to x, or P sub x, or P plus x. The sum of Px over all values of x is equals to 1. That is, the probability that x can take a specific value is P sub x, and that is P sub x is non-negative or real x, and the last summation of probability should be only equal equal to 1 should be only equal to 1. If 2 coins are tossed, set all possible outcomes, where tail represent as T and head represent as H. If you are interested to tails, what are the possible outcomes?
Parts of the coin. One is the tail and the other one is the head.
Did you represent the parts of a coin, the tail and head?
It's the 2 coins. So we will toss this one and let's find out what are the possible outcomes.
If a 2 coins are tossed, set all possible outcomes. Possible outcome of 2 coins are tossed. Tail and tail. Head and tail. Tail and head. Head and head. Let's continue. S represent possible outcome or sample space of the 2 coins are tossed. Tail as a T and head as an H. Look for the number of tails and we make a table chart. So this will be the table chart. So we will write sample space, number of tails. So we will look for the number of tails for letter T. So again, we will write the sample space of a coin, the tail and tail, the tail and head, head and tail, head and head. And we are looking for the tails. The problem is we are looking for the tails. So how many tails? 2. Tail and head. So 1 tail, you will write that 1. Head and tail. Only 1 tail, you will write 1. Head and head, so there is no tail, you will write 0. Let's continue. S represent possible outcome or sample space, where tail represent as T and head represent as H. So this is the sample space. Number of tails represented as T, and then piece of X and piece of X. Again, tail and tail. How many tails? 2. Tail and head. So how many tails? 1. Head and tails. So tails is only 1. Head and head. So there is no tails. You will write 0. And then probability of X. So seems to be that we have already made 1, 2, 3, 4. So divided by 4, divided by 4, divided by 4, divided by 4. And this one represents as 1. This represents as 1. This represents as 1. This represents as 1. So we will write, we will add the 1. 1/4 plus 1/4 is 2/4. For the lowest term of 2/4 is 1/2. And then you will write again 1/4 here. And for the 0, 1/4 here. Again, let's continue. Note, the summation of piece of X should always be equal to 1. So we will add. So again, we will add this one, 1/4, 1/4 plus 1/4 plus 1/4. So we will add 1/4 plus 1/4 plus 1/4 plus 1/4. So 1 plus 1 plus 1 plus 1 is equals to 4. Since that they have the same denominator, you will write only 4. So 4 divided by 4 is equals to 1. So the summation of the probability should be always equal to 1. Probability distribution. So x represent a 0, 1, 2. And piece of x is equals to 1/4, 1/2, and 1/4. So we will make a table. We will write here as an x and piece of x. So again, we will place there a 0, 1, 2. And then piece of x, 1/4, 1/2, and then 1/4.
This is 3 coins. Then you will solve and look for the possible outcomes.
What are the possible outcomes if 3 coins are tossed? Set all the possible outcomes and look for the heads. Apply it in the table chart. Possible outcome of a 3 coins are tossed. Head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, and tail. So the possible outcome for 3 coins are tossed in a given chart. So we have the sample space, number of heads as h, and then probability of x. So again, we have heads, heads. So number of heads will be 3. Heads, heads, and tail. Number of heads will be 2. Heads, tail, heads. Number of heads will be 2. Head, tail, tail. Number of heads is only 1. Tail, head and head, only 2. Tail, head, tail. Number of heads will be 1. Tail and head will be 1. Tail and tail, so there are no heads, you will write 0. So how do we make, or how many sample space that we need? 1, 2, 3, 4, 5, 6, 7, 8. So divided by 8, divided by 8, and so on. So we have 1 and 1, 1, 1, 1, 1, and you will write 1. So these are the continuous of probability distribution. Okay, let's have an explanation. So we have the sample space, the number of heads as an H and represent as an X, and then probability of X. So we have the head and the head. So number of heads is 3. Head and head. Number 2, head, tail, head, we have 2. Head, tail, tail. So only one head, you just write 1. And then tail, we have head and head. So there are 2 tails. Tail, head, and tail, only one head. And then tail and tail will be head. And the number of heads, only 1. Tail and tail, so there are no heads. You will write 0. So how many samples do we make for this one? How many? 1, 2, 3, 4, 5, 6, 7, 8. So divided by 8, divided by 8. And then, so 1, 1, 1, 1. You will write 1 over 8, 1 over 8, and 1 over 8. So note, so for x, take note guys ha, for x and 0, so where do you have the 0 here? This is the 0. This is only 1 over 8. And then all 1, 1, 1, 1 is 1 over 8, 1 over 8, 1 over 8. So add all x of 1, which is 1 over 8 plus 1 over 8 plus 1 over 8 is equals to 3 over 8. Number 3, add all x of 2, which is, so we have 2 here, we have 2 here, and then 2 here. So all 2 is 1 over 8, 1 over 8, or 1 over 8 plus 1 over 8 plus 1 over 8 is 3 over 8. And for number 3, we have only 1 over 8, we just only write 1 over 8. So continuation of probability distribution. Again, for 0, for the x, we have 0, 1, 2, 3. So we have piece of x. In 0, again, it's only 1 over 8. In 1, it's 3 over 8. And then 2, it's 3 over 8. And then 3, it's 1 over 8. So the summation of probability of x is equals to 8 divided by 8 is equals to 1. Because if we will add 1 plus 3 plus 3 plus 1 is 8. This is the 8. And then divided by 8 is 1. So 8 divided by 8 is 1. Or the summation of probability x is 8 over 8 is equals to 1.